Hello. Uh, yeah. Send. Check the new one. Click. Yeah. Okay. Uh, Everyone, can you hear me? Can you hear me? Okay, faster. Start in 2 minutes. Just 2 minutes. Sorry everyone. I don't know. I directly started off the video. It was just 1 minute left. I wanted to start, and I accidentally pressed a button. I don't know which one. It stopped. Extremely sorry, everyone. Extremely sorry. I believe everyone can hear me now. If you can just type something. If you can hear me clearly, can type anything in the chat box. Anything. If you can hear me clearly. If you can hear me clearly, can type anything in the chat box, everyone. Uh, Let me see. Okay. I believe now. Can hear me. Okay, no worries. I think there's some problem with the everyone that's here. Okay. Now let's believe everything. Let's start off with the session for now, everyone. I believe everyone can hear me clearly now. So let's start. First of all, I'd like to introduce myself. I'm Teacher Smith from Kangaroo Learning Center. And today we are going to discuss about the round 2 topic, that is geometry, everyone. Now, why suddenly we are talking about round 2? Round 1 will be first and then comes round 2. But the challenge is from round 1 all the way to round 2, the dates, the gap, you can see the time is very less to prepare for round 2 if we just focus on round 1 topics. There are some topics that are very new that are tested in round 2, so we have to prepare for those topics as well. So how we can achieve this is the question. Now, in order to do this, what we can do is we can start the preparation of round 2 from now on. Now, the topic that we'll be discussing for today is geometry. Now, why geometry? Because here in geometry, the skill that we require to solve any question is good observation. Regarding any of the type, any of the model, the thing that we have to pay attention on is good observation. Now, which is the part that we have to look for? Let's just see. Two of the important topics that we'll be discussing today is about perimeter and area. Now, regarding these topics that are present here, the two of the topics are very important, and the shapes that we'll be discussing will be very important for the foundation as well. So, let's see what is the word perimeter and what do you mean by the word area that is here. Starting off with the perimeter. Now, for the perimeter, the thing that we'll be discussing now is something off topic. Let's just imagine. No need to imagine first of all. Now it's the vacation time. Everyone is enjoying vacation. Now let's just think. We are sitting in a broad sunlight. It's a vacation. Exams are over. Let's see. Now in the garden, you are just sleeping. But one day what happens? Normally you sleep in the garden, you take the sunlight, everything is going well. But one day what happens is there are some of the things tries to enter in your garden, let's say from outside. It can be ant, it can be mouse, any of the thing, rabbit or anything tries to enter your garden. And now at this stage you are like, oh, My garden is getting ruined. So what should I do? So what you do is you try to fence the garden from outside everywhere. We try to fence it around. Now when you try to fence, the garden that you have is of length and width. The length is nothing but 5 meters and the width is nothing but this 4 meters. This is the width. Now the thing that we have to pay attention on is I need to fence the garden. Now to fence, how many meters of fencing do we need? The length is 5 and the width is 4. So how many meters of fencing will require? This is the question. So first of all, we can observe this length is nothing but of 5 meters and this part we will fence totally. Then comes this line, this vertical line that we have to fence. But the question arises, what is the length of this line that is present here? What is the length? Perfect. The length is still 4 meters. Now, regarding this part, this is also 5 meters. And lastly, this is also 4 of the following meters. So if I ask you everyone, the total length that is needed to fence everything will be how much? The total fencing. Can anyone tell? Oh, here it's 5 and 5 meters is how many times? Think. It's just 2 times. What about 4 meters? 4 meters will be how many times? Here on this side, here on this side, there are 2 of the following 4 meters. So 5 meters will be 2 of the following times and then 4 meters will be again 2 times. So this is the total fence that we will require. And if we calculate this, what it will be? Perfect. 5 times 2 will be 10 plus 4 times 2 is 8. So the total fence that we will require will be 18 of the following meters. Now the question is, what does this 18 meter represents? Any idea? This 18 meter is nothing but the total fencing of the outer boundary. And this fencing of outer boundaries is called as the perimeter. Perimeter is nothing but if we have to fence the outer boundaries. What is the length of the fence that we will require is nothing but called as the perimeter of the shape. So you calculate any of the shape. If you calculate the boundaries, this is nothing but calculating the perimeter. Now for the regular shapes. For instance, rectangle. Let's say there is a rectangle of 5 centimeter and 8 centimeter. That was just the garden. This is an actual shape where we have to find out the perimeter. So what will be the outer boundaries? First of all, in a rectangle, we all know opposite sides are the same. So if this is 8 centimeter, what is the value of this side? Perfect. Rectangle, 8 centimeter again. So this is 8 centimeter. Now, what will be the distance? Okay, so this is 8. This we don't know. This is 8. This is 5. So, since this is opposite to 5, this is also 5 centimeter. Now, if I want to calculate the total boundaries, the total length, what we should do? Firstly, we should see the 8 centimeter, this length. The length is how many times? Perfect. The length is 2 of the following times. That is, 8 is here, 8 is here. So there is 8 2 times. Then comes the next part, that is this 5. 5 is how many times? Perfect. 5 is just 2 of the following times. So what we can do is just 5 times 2. And now if I want to calculate, 8 times 2 is how much? Perfect. Good answer. 16. Then 5 times 2 is how much? 10, and this is nothing but 26 centimeter. So this is nothing but calculating the perimeter. Perimeter is simply nothing but calculating all the outer boundaries of a shape. So let's just see how we can calculate this part directly. Let me change the color of the pen. Let's say this 8. What does 8 represents? The length or the width? Perfect. The 8 represents the length. So it's nothing but length. What about this 5? What does this represent? Perfect. You can call it as width. Or there is another word for it that is called as breadth. So this is nothing but breadth. So what we can understand? The length, when we multiply by 2, now will this 2 change? Of course not, because in a rectangle, the lengths are the same. And there are how many lengths? There are always 2 lengths. That's why this will be always multiplied by 2. Now regarding the breadth also, this is the value of breadth and it will always be multiplied by 2 because there are 2 breadths. So length times 2 plus breadth times 2, we get the perimeter of the rectangle. Now, after understanding this foundation, now we can have a look at the summary. That is the perimeter. Perimeter is nothing but just calculating the outer boundaries of the figure. And in order to calculate the perimeter of a rectangle, we can write down the formula. Everyone, you can take this note down. That is, rectangle is nothing but the perimeter is length. And the length is how many times, class? 2 times. Perfect. The length will be 2 times. And what about the breadth? Breadth will be how many times? Perfect. Again 2 times. So I can write down breadth is nothing but again 2 times. Now, what we can observe here? Oh, so what we can observe here? We can find out the perimeter of the rectangle. So using this foundation, let's see the question now. Let's hear. The question says, let's try to understand. The length of a rectangle is 2 times the width. How many times of the width is the perimeter of the figure? Now, this is an actual GP question. GP, which was tested in round 2, 2021. So here the question says the length is given to us and the relation is length is 2 times of the width. The length, the multiple relation is 2 times. How many times of the width is the perimeter of the figure? So here I want to calculate the perimeter of the figure, then compare it with the width. But the problem is there are no values given in this question. There's not a single value that is given. But there is a multiple relationship given. So let's see how we can use the multiple relationship to find out the perimeter of the figure. So let's try to understand this. See, regarding the length and the width, the relation is 2 times. So let's say in this length and width, which one will be smaller? Which one is smaller? Is the length or is the width? Perfect. It's the width that is smaller. So let's say if I consider the width to be just 1 unit, 1 u. So what will be the value of the length then? Length is how many times? 2 times. So it will be how many units? Perfect. 2 units. So I can write down it as 2 units. Now the question is, we have to compare this with the perimeter of the shape. So I need to figure out what is the perimeter of this part. And we know to calculate perimeter, which part we have to calculate? Oh, the outer boundaries. So I can find out the outer boundaries. So here, this is 1 unit which we can find out. This part we know. Regarding this length also we know. Now this, what is the value of this part? Perfect, it's just opposite, so it's just 1 unit. Now comes the next part, that is this line. This is the outer boundary. Let me highlight it for you. The outer boundary looks something like this. This part, this part, this part, this part, and then comes this part, this length, then comes this length, and then comes this length. Now this is a challenge. We don't know what is the value of this part. Now let's just figure out which other values do we know. Let's see this one. What is the value of this part? Oh, the question says that the length is 2 times and length we know it's 2 units. So I can mark it as 2 units. Now comes the width again. So width is how much? Perfect. Width is just 1 unit. So I can write down 1 unit. Now again comes the length that we know that is 2 units. But again, this smaller part, do we know what is the value here? Of course not. So let me highlight it with a question mark. So regarding the perimeter, I can find out every single value, but the two question marks here are missing. So what we can observe? So the thing that we have to pay attention on is the total length. The total length of this side is nothing but 2 units that we already got. So the opposite length, the total will be how much? That is this part. This part will also be 2 units. But the thing is, I need to find out these two unknown question marks. But in this 2 units, which part we don't need? Perfect. The only part that we don't need is this one. And do we know the value of this part? Of course, yes. Here, this is the width, and this is opposite to this 1 unit. So this represents 1 unit. So there's one thing we can observe. The total length is 2 units, and the part 1 unit is removed. So what is the value of this two question marks? Perfect. The two question marks is nothing but just 1 unit. That is nothing but the question mark simply is 2u minus 1u, which is equal to 1 unit. So for this two question marks, now we know the value is just 1 unit. Now class, can we find out the perimeter of this shape? Let's just see, calculating just the outer boundaries. So if I want to calculate the outer boundaries, okay, let's start with this. Okay, 2 units we have. Then there's this 1 unit on the upper side, that is here. Then there is this two question marks that are present, and we know the value of this two question marks together is 1 unit. And then comes this outer boundary, that is 2 units. Then comes this part, that is 1 unit. Then let's calculate this part, that is nothing but 2 of the following units. And lastly, we have this part remaining, that is 1 unit. Now the thing is, this simply represents the perimeter of the entire shape. Perimeter. Now, if this represents the perimeter, let's just calculate 2 plus 1 plus 1, it's 4, 5, 6, 7, 8, 9, 10. So the total is 10 units. So this is just the perimeter of the figure. The perimeter is nothing but 10 units. But the question is, it's asking how many times of the width. Of the width is the perimeter. So width was how many units? Perfect. We already set the value of the width, that is here. The width is just 1 unit. So width is 1 unit. Perimeter is 10 units. How many times it is bigger? Just 10 times. So here the answer that we are looking for is just 10 times. So what we can observe, the previous example that we saw for the rectangle was of a regular shape. And in regular shapes, calculating perimeter with the given value is very simple. But the challenge comes in this question because the question has an irregular shape. It looks something like a T. So it's quite difficult to find out the perimeter. So the thing that we do is we try to label each and every part. First of all, whenever you see perimeter, try to draw the outer boundaries and then try to label each and every part. This is the most important tip, and not just for this question, for any question of perimeter, remember, we have to label. Labeling is very important. So this is the summary for the question. That is the most important part, label. And apart from label, there is the relation of rectangles that we have to understand. So in order to summarize this question, here the question deals with the perimeter, and this perimeter deals with the outer boundaries of the figure. Now, moving on to the next part, as I just said, this completes just the first question. The next part that we'll be talking about will be area. Perimeter, we know. Perimeter is nothing but calculating the outer boundaries. Simple. Okay. Now, let's see what do you mean by the word area before we start off with the question. Let's understand what do you mean by it. So let's say there is a wrapper, chocolate wrapper. Okay, and I think everyone likes chocolates. I believe everyone. Okay, so let's see there is a chocolate wrapper, and I have a small chocolate cube of this size of 1 times 1. Okay, so there is a chocolate wrapper which is of 4 centimeter and 3 centimeter length and width, and this small cube. Now my question is, this is just one piece. This is one piece. Now my question is, there are how many pieces that we can fit inside this chocolate wrapper? The big chocolate wrapper is of 4 centimeter times 3. So how many pieces we can fit? How to find this out? Okay, let's just see. Here what we can observe, this is 1 centimeter which is in length. But the total length of the wrapper is of 4 centimeter. So my question is, how many of the pieces that we can fit at this stage, at this part? In the horizontal line, how many pieces we can fit? Perfect, very good answer. The pieces that we can fit is 4. There are 4 pieces, 4 centimeter. Now in the vertical line, there will be how many pieces? Here already there is one piece and it's of 3 centimeters. So how many we can fit? Perfect, total 3 pieces. So if I want to calculate the total number of pieces that we can fit will be how much? So first of all, in one layer, there are 4 pieces and there are 3 of the following layers. So it will be how many? Perfect. Some students say it's 4 times 3. But we can also cross check it by just putting in the pieces, and here we can get that the total number of pieces, if you count, will be nothing but just 4 in this way, and there are 3 layers, so it's 4 times 3, which is nothing but 12. So this is the number of chocolate pieces that we can fit inside the wrapper. So what we can understand from this part, what we can see, the chocolate paper had the dimension of 4 centimeter and 3 centimeters. But the small squares of 1 times 1, this is a small square, and this small square is of dimension of 1 centimeter. So the number of chocolates that we can fill, that is 12, is nothing but the area we can say. So what is the meaning of area? Area is nothing but the number of this 1 centimeter squares that we can fit inside a given shape is called as area. And area is calculating the surface of the figure. Calculating the surface. See, perimeter was just outer boundary, but area is the inside surface that we have to get. So with this, let's try to see another example where we have a floor of 5 centimeter and 4 centimeter. And I have to fill small tiles of 1 centimeter square. See, there's a square of 1 centimeter. So how many we can fill? So first of all, as I said, see, if I want to fill it in this horizontal way, how many pieces we can fit? Perfect. This is just 1 centimeter. So 1 centimeters of how many? Of 5 we need. Then this is just one layer. So in this vertical manner, how many do we need? Oh, 4 centimeters. Very good. 4 of the following tiles. So see, if you want to find out how many total tiles that we can fill here, see, in the first row, that is the first one, there are 5. And there are how many of the following rows? Perfect, 4 rows. So in one row, there is 5. There are 4 of the following rows. It's 5 times 4, which is nothing but in total of 20 centimeter. And this is the calculation that we need in order to find out the area. So from the first example, we can understand what do we mean by area. And in the second example, we can dive into more deep to see how we can calculate area by just multiplying. There's also another thing that we can understand is its unit, that is centimeter square. So for area, this is how we can find out if we have the length, then if we have the width, that is the breadth, then we can calculate the area, that is length, which is multiplied by breadth. So let's do a quick practice. Let's do it. Let's say there is a rectangle of 3 centimeter, 2 centimeter. You can tell me how to find out the area. Oh, perfect. What we can do is it's just 3 times 2, which is nothing but 6. Most of you got it correct. Very good. I like it. So what we can do is we can just multiply to get. So this 3, what does this 3 represents? Length or the breadth? Always remember, the longer side is called as the length. So 3 represents the length. What does this 2 centimeter represents? Oh, some students will say breadth. Some students will say width. I'll tell you, both of you are correct. So here it's called as the breadth, or else you can say width. Now, in order to find out the number of squares that we can fill of 1 times 1, this is 6. So 6 represents what? It represents the area of this rectangle. And we can just multiply in order to get the value of area. So students, everyone, just write down the formula. To calculate the area of a rectangle, it's nothing but length multiplied with breadth. You can get area. But the question is, this is just for rectangle. What happens if there is a square? So let's just see. Let's say if there is a square, the property still remains the same because you are just fitting 1 centimeter squares every time. So if we just want to fit a 1 centimeter square, the property remains the same, just value has changed. In a square, the length and the width, that is the breadth, it's of the same size. So if we want to calculate area here, which formula we can use? It's nothing but 4 times 4. It's just the same thing, that is length times breadth, but the value is same. So here there is a part that we can use. And which part it is? This 4 centimeter represents just the side of the square. And for squares, we know all the sides are the same. So if all the sides are the same, so here this 4 and 4 represents side times side. Side multiplied with side is called as area. So regarding area, what we can do is there are 2 of the following values, length and breadth. No matter what, if the length and breadth is same, it becomes a square. But we can just multiply it to get the value of area. Now, this one thing also we can understand. See, if length is given, breadth is given, we can find out area. But let's say if length is given and area is given, can we find out the breadth? Perfect. What we can do is area 6. We can divide by 3 and then we can get 2. So we can get the breadth also. So if we know breadth and if we know area, can we find out the length? Perfect. It's just again divide. So what we can observe here is in the formula for a rectangle, we have to know just 2 values. Just 2 values, either length, breadth or area. If we know any 2 values, we can find the third one. Find unknown. So this is for rectangle. But there's something interesting about squares. Just check. For squares, there's one thing that we can observe is this 4. See, the sides are the same. So if I know any of the side, we can find out the area. And if I know any of the area, can we find out the side? Perfect. Area. If I have the area, the question arises how we can find out the side. So let's just see how we can do this. Let's say this is a square of area 16 centimeter square. I need to find out what is the side here. So we know the formula for area is nothing but side times side. But the problem is both the sides are missing. So let's just see. If I have side and if the side and side is multiplied, which is of the same value, the answer should be 16. Now comes the very important question to every one of you. Try to answer this question. There are 2 numbers that are multiplied. And after multiplying, you get the answer 16. But the thing is, both the values should be same. Because in a square, sides are same. So can anyone tell me which two same numbers when we multiply? The answer is 16. Think. Which two numbers we should multiply in order to make sure that the side is 16? Take a guess. 2 times 2, 3 times 3. 4 times 4. Many of you have guessed it correct. It's nothing but 4 multiplied with 4, which is equal to 16. So what we can observe from here, if we have side, we can calculate the area easily. But the problem is, if we have area, to calculate the side, we have to think about using the two same numbers. When we have the two same numbers, multiplying it, we can get the area. So here, for squares, the thing that we can remember is, if we have side, we can calculate area. And if we have area, we can calculate side. So if we know one, we can get another one. This is part we can understand. So let's summarize this. Area is nothing but calculating the number of 1 times 1 squares in a figure, and also for a rectangle. Recollect. What was the formula for rectangle? If you have length, if you have breadth. Perfect. Just multiply. Length times breadth. This is for the area. Now, in this, out of these three values, if we know just 2, we can easily find out the 1. So, the part that we have to remember is know 2 to get 1. Now, this is for the rectangle. What about square? For square, the part we have to pay attention on is area is nothing but side times side. Now, if we know side, can we find out area? Perfect. But if we know area, can we find out side? Perfect. So here in area, the part we have to pay attention on is no one, and we can easily get the other one. So every one of you can write the formula down in your paper for now. Just 3 seconds. Just take a picture. No worries. I'll share all the details of the formula and also the questions after the class. So stay tuned. All the materials will be sent after the class. Okay, no worries. Let's just see the question that we have now here. Let's have a look. The area of the square is 36 centimeters square. It is then split into equal halves and rearranged. What is the perimeter of this new figure on the right? Let's just understand the question. See, there are two figures. There is figure 1 and there is figure 2. In figure 1, there is a square. And the area of the square is nothing but 36 centimeters square. The question is, the square has been cut from the middle. And now we can see two rectangles. And now these two rectangles are placed side by side in order to find out, in order to make a rectangle. So this is a rectangle now. Now the question is, we have to find out the perimeter. Now let's just recollect again. Perimeter. Finding out perimeter means finding out what? The outer boundaries, the outer things. So, in order to find out the perimeter of this rectangle, what are the things that we need? We have to find out this part. Then we have to find out this total number of length that is here. Then we have to find out this vertical line. Then we have to find out this bigger vertical line. And then lastly this line. So this is nothing but calculating the outer boundaries of the figure. But the thing is, do we know the side? We don't know the sides here. We don't know any of the sides. We don't know the length. We don't know the width of this rectangle. But let's just recollect. Let's just go back to the shape that it came from. Let's go back. So if we look at the square that is present here, the area of the square is given to us. So if area is given, can we find out this length that is present here? It's the same length that is present in here. Can we find out the length of this square? That is the side length. Can we? Let's just recollect. What was the formula for area? Area is nothing but, we just know, that is side multiplied with side, which is nothing but 36. So area we know. If two of the sides are multiplied the same number, we can get 36. Can anyone tell me? Which two same numbers? When we multiply, the answer should be 36. Think. Two same numbers multiply. Perfect. 6. 6 when multiplied with 6, we can get 36 here. So the side that we are looking out for is nothing but it's just 6 times 6 giving us 36. So the side that we are looking for, what is the value? It's nothing but 6 centimeter. So the square has the side length of 6 centimeter. Now tell me, if the total length we know is 6, this is 6 centimeter. Now this has been cut from half. This line that is present here, it's cut from half. So can anyone tell me what is the width here? Perfect. It's just half of the length that is present. So if you want to find out the breadth of the rectangle, that is this part. Breadth of rectangle is nothing but here. It's 6 divided by 2, which is equal to 3. So here, this part is nothing but 3 centimeter. And remember what I said. Label. Always. As soon as you get the value, try to label it on the figure. Now, let's try to label all the values that we know. So for the length of the square that is present here, from here all the way to here, what is the value? This is 6 centimeter. Also coming back here from this part to this part, again 6 centimeter. Now comes the width that we already got is 3 centimeters. So we have this as 3 centimeter. Again the length, it's the same 6 centimeter, 6 centimeter, and this as 3 centimeter. Now we know all the measurements of this new figure that becomes a rectangle. So now can we find out the perimeter of this shape class? Can we? Let's see. So here what we can find out is, to find out the perimeter of this shape, it's nothing but adding all the outer boundaries. So make sure you don't miss any of the values. So for that, let's just try to see how we can do. See, this is 6 centimeter. This 6 centimeter is how many times on this new figure? In this new figure, you can see 6 centimeter how many times? Perfect. It's 1, 2, 3, and this 4. So here, the 6 is 4 of the following times. Then comes this 3 centimeter. The 3 centimeter is how many times? We can see it's here and also it's here. So here, this is nothing but 3 times 2. And now, if I ask you, if you want to find out the value, it's nothing but 6 times 4. 24 plus 3 times 2, 6. So 24 plus 6, answer first. Perfect. That is 30 centimeter. So what we can observe from this question is, it's about the perimeter. But the most important thing is about finding out the length, the side length. To get the side length of any of the square that is present, the part that we can do is, from area we can find out the side. As normal situation, from side we can get area, but from area also we can find out side in a square. So let's try to summarize. For this question, yeah, to find out the area in a square, it's side times side. But the thing that we have to pay attention on is, if we know any of the value, we can find out the next one. From side get area, area get side. So this is what we can understand. And that completes the second question about area. Now moving on to the third one. The question is, what is the perimeter? What is the perimeter? Okay, perimeter I know. Okay, area also we know. Let's just see. I want to find out perimeter. Perimeter means calculating all the outer boundaries. Okay, perfect. So here, this side length that is present here, do we know its measurement? Wow, we are so smart. It's 5. Here, do we know the measurement of this line? Wow, we are again smart. It's already given 7. Again now, what about this part? Do we know its measurement? Ah, it's just opposite of this shape. So if this is 5, this also is 5. This also we know. Now comes this part. Do we know what is the measurement of this part? We are not sure. It's not even given in the figure. Now let's just move to this one. Do we know what is the value of this one? Again, not given to us. Again, question mark. Then comes the measurement over here. What is the length here? Wow, 3. What is the length here? Oh, wow, 1. What is the length here? So this 3 is opposite to here. So this becomes also 3. Perfect. Do we know what is the measurement here? No. So also this is question mark. What about this part? Oh, this is also 3. This also we can get. What about this? Oh, it's 2. We know. And lastly, about this one, do we know its measurement? Oh, opposite. So this also is 3. Now, there are 3 of the following question marks here. 1, 2, and 3. Can we find out the perimeter of this shape? Oh, quite challenging. Quite challenging to find out because there are 3 unknowns in this shape. Because the shape is not a regular shape. It looks something like E, you can say E. Looks something like E. It's not a regular shape. The shape that we saw now in the example was a rectangle, was a square. So we can find out. But the thing here is, it's not a regular shape. So let's see. Let's dive deep into watching how we can find out the perimeter of irregular shapes. So let's just see. Let's say there is a rectangle. There is a rectangle of, let's say, 5, and this is 7 centimeter and 5 centimeter. But the thing is, the shape is a bit incomplete. It looks something like this, where this side is nothing but, let's say, 4 centimeter, and this is nothing but 3 centimeter. Now my question is, we have to find out the perimeter of this shape. So we know the length here. We know the length here. Do we know what is the length here? Oh, we can find out. This simply is 5. This simply is 4. So we can get the value of this part. Then this is 3. We know. This is 4. We know. What about this part? Oh, also we can get that is this is 7, and from the 7 we can remove this 3, and then we can get the value that is here. Now this is one way of solving the question where we can actually find out the value of the parts. There is another way also. Let's just see. See, what we can do is, the shape currently is not a regular shape. It's an irregular shape. So what we can do? We can try to think about it as a regular shape. Currently, the shape is incomplete. It looks like a staircase. So, if this shape was complete, can we think about any shape if it was there, if it was complete? You can think of it as a chocolate bar. A chocolate bar from where you took a bite from this area. You took a bite, and now this is incomplete. But let's say if you didn't take the bite, which shape it would have been? It would have been a rectangle here. So here what we can observe, if this was a complete shape, we could have got a rectangle that is present. That is a complete shape. Now, if I ask you, here, if I want to find out what is the value of this part, this length that we have filled, what is the length here? Perfect. It's just opposite to this 3. So here what we can do is, the 3 centimeter is nothing but a vertical line. This vertical line we can move up, and then it will be removed from here and it will be placed here. So it will be complete. Now the same thing here. This length, the dotted line, what is the measurement here? Oh, it's opposite to this 4 centimeters. This is also 4 centimeter. Now also this is a vertical line, and this vertical line we can move. We can move left and right. So here we can move into this part. So now this is gone from here and can be filled here. So can anyone tell me which shape it becomes now? If I move both the parts outside, it forms a complete rectangle. Now for this rectangle that is present, can anyone tell me how to find out the perimeter of this complete rectangle, this one? Oh, we know for a rectangle it's nothing but this is 5. And the opposite is also now 5 centimeter. So there is 5 centimeter how many times? Perfect. There will be 5 centimeter 2 times. Now comes the 7 centimeter. The length here is 7. And what about the total part? That is this one. Total is also 7 centimeter. So there's 7 centimeter how many times? 2 times. Very good. So the 7 will also be 2 times. Now if you want to find out total perimeter, which sign should I put? Plus. So here if we calculate it's just 10 plus 14 which is 24. That is centimeter. So class, the part that we can understand from this example, see the thing, the irregular shape looked like a staircase. And what we did in order to complete it is the vertical line. The vertical line that was of 3 centimeter, what we did is we tried to move up or down. So whenever there's a vertical line, you can move up and down in order to fill the shape. So if you have vertical line, you can move up or down to fill the shape. But let's say if you have, oh sorry, this is a horizontal line. But if you have a vertical line, how you can move? You can move it on right or else you can move it on the left. So here we can move it left or right in order to fill the shape. And that can complete the question here. So in our question also, there are some parts that are incomplete. There are some values that are incomplete. That is this, this, and this. But as we just saw, we can move. We can move to make it into a complete shape. But the thing is, this is quite irregular. There are some bites that have been taken. A bite has been taken from this part and from this part. So if I try to complete the bite, if bite was not taken, bite, which shape it would have been? Oh, it completes to become a rectangle. But the thing is, if I want to complete the rectangle, do I know what is the value here? What we can do? We can move this 1 unit that is up and this can be filled here. So this is a total part that can be filled here. What about this 2? This 2 is a horizontal, sorry, this 2 is a horizontal line. And this also we can move to complete it into the shape. And this also is nothing but how much? Also 2. So this is 1, this is 2. But the thing is, we can fill the part. We can fill all the parts that are present. But the part is, if this is 1 and 2, let me erase this off quickly. If this is 1 and this is 2, this we know is 5. This we know is 7. This we know is 5. What about the total length? That is this one. What about it? What is the length? Oh, it's just 7. So, what we can do? This 1 centimeter is not existing here now. We have moved it over here. Same thing with the 2. It doesn't exist here. We have moved it here. So, this is not here. This is not here. Rest, all the values are present. So, let's see how we can find out the perimeter of the irregular shape. That is the part 1. Part A, that is about perimeter. Now, if we want to find out perimeter, let's just see. There is 5. Now, can anyone tell me 5? There are how many 5s in the figure, in the entire perimeter? Perfect. There is 1 5 here and there is another 5 here. So, 5 is 2 times. Oh. Now, let's go to the 7. The 7 is how many times? Perfect. 7 is here and there's another 7 that fills this part, this part, this part, this part, and this part. That is 7 times 2. 2 times. Now my question is that all? Is this the only parts that has to be fenced? See, this 5, 7, 5 and 7 we have filled. But what about the length of 3? This 3 also exists here. And there are how many 3's inside this shape? There is 1, 2, 3 and lastly this 4. So it's 3, 4 times. And now if I want to calculate the perimeter, the total perimeter of this shape, what should we do? Which sign we should put? Just add. Just add. So now here, 5 times 2 is how much? It's 10. 7 times 2, think, perfect, fast, 14. Plus 3 times 4, again is 12. Now, if I want to calculate the total perimeter, let's just add the values. Okay, 10 plus 14, okay, 34. 34 plus 12. Oh, it's nothing but how much? Oh, 10 plus 14 is 24. 24 plus 12 is 36 centimeter. Oh, there's no units. There is no unit. So let's just not write any of the unit. The answer is nothing but just 36 units. So this completes just the part A of the question where we have found out the perimeter. But the thought process that we have used, the thinking method, is nothing but out of the total perimeter, there are some bytes that are present. And to fill up this bytes, what we did is we tried to imagine it as a complete figure. And then after imagining, we try to push out the parts. So the method that we have used here is nothing but called as the push out method. Push out method. Now what does a push out method is? A push out method is nothing but something where we push out the horizontal line up down and vertical line left right. That's it. Now, moving on to the part B of the question, that is about the area. Now, let's just think how we can find out the area. To find out the area of this part, okay, where did the question go? Okay. To find out the area of this part, let's just see. Let me erase everything from the figure. No need now because now we'll be finding out the area. So, let me delete all the values. Okay. Now let's just see how we can find out the area of this shape. See, the thinking method. In perimeter, what we did, we tried to think it was a chocolate. We took a bite. And after taking out the bite, we have to find out the perimeter. But let's just see. In order to find out the area, is there a formula directly to calculate area of the shape? Is it? It's not. The shape is irregular. It looks something like E. So we cannot calculate the area of this shape directly. So what we should think of? Let's just take the same method. The paper took a bite. Let's just see if I didn't take a bite. What would have happened? It would have been a complete rectangle. It's just like calculating the area of the complete rectangle. That is area of rectangle. Where can we find out the area of the complete rectangle without the bite? Oh, we know the length and we know the breadth also, that is here. So we can find out. But the part is the area. It's not complete. There are this part that we don't need. There is this part also we don't need. So if you don't need this part, can we find out area of these two parts that we don't need? Oh, the shape of this area. Let's just focus here. Let's say if I call this as area A and area B. Let me highlight it out. This is nothing but area A. And this is nothing but area B. Can we find out area of A? To find out, we need length, we need width. Do we have? Oh, length we have. Both the values we have. So can we calculate area of this A? We can. What about B? We know its width. Do we know its length? Do we know this part? It's the same thing. It's this is 3, this is also 3. So we technically know the length and width of both the parts. So can we calculate area of the part A? Yes, we can. What is the formula? Oh, it's nothing but 3 times 1. What about part B? How to calculate the area? Here. Oh, its length we know, width we know. It's nothing but 3 times 2. And how we can find out the total area of this A and B? With sign I should put in the middle. Oh, just plus. So here what we can do is 3 times 1 will be how much? Oh, it's 3 plus 3 times 2 is how much? Oh, 6. So if we calculate the part, that is just 9. So 9 is nothing but the area of A and B, but we have to find out area of this part. So the total area of the rectangle is how much? Oh, area of rectangle is nothing but 5 times 7. That we can easily find. This is length, this is breadth. But which part, which area we have to remove in order to get the area of the shape? That is A and B, and A and B is 9. So we just have to remove 9 from the area of rectangle. And if we remove 9, what is the answer? Let's just see. See, 5 times 7 is how much? This is 35. And if we remove 9, what will be the answer? 35 minus 9 is nothing but 26. And that is nothing but in units. So, what we can observe from this part B, that is about area. See, the thought process remains the same for perimeter and for area. That is, you just think of it as a complete shape. Try to include it in any regular shape and then think you are taking a bite. After you take the bite, then you think if the bite was not taken, what regular shape it would have been. So you find out the total part and then remove the parts that we don't need. And this thinking method is called as whole. That is calculating the total minus the part that we don't need. We can get the area of the irregular shape. Total minus the part that we don't need, we can get the area of irregular shapes. So let's just summarize for this question. For perimeter, here the part that we can summarize is, if it is an irregular shape looking like staircase, you can use the push out method. And in push out method, if you have vertical lines like this, you can move left and right. What about horizontal lines? How we can move? Oh, top and bottom. So here, horizontal lines can be moved to top and to bottom. So this is what we can understand. Now, this was just about the area, perimeter of irregular shape. What about area of irregular shape? Which thinking method did we use? So, what can we do is, we can think that we can find out the total part, the whole. And then from the whole, if it's an irregular shape, we can remove the shape that we don't need. That is the part. So here the thought process is whole minus part. And then we can find out the area of the irregular shape. So class, there are two important things we can understand with respect to geometry. Perimeter, area. Whether it's regular, whether it's irregular, we have to compare it with the regular shape. So with all said and done, let's see the last question. The last question for today is about the area. Now here the question is, the area of the several rectangles is provided below. Find the total area of the three shaded part. Oh, we have to find out area of the three shaded part. Let's say this shaded part is A. Oh no, we cannot see it. Let me highlight it more. This is A. Let's say this part is B and this part is C. So basically there are three parts, A, B and C. And we have to find out what is the total area of these three parts. Oh, but the thing is, area is given. Let's say if I want to find out area of the rectangle A. See, it's a rectangle. Which are the two values we should know to find out area of A? Oh, we should know the length and we should also know the breadth. But do we know any? We don't know. Regarding B, do we know its length and width? Also don't know. What about C? Also don't know. But there are other areas that we know. Let's just take an example. This is 8. This area is 8. The area of the rectangle is 8. Can anyone tell me which two values, when we multiply, we can get 8? Okay, some students will say, okay, we what can think of it as, okay, this can be 1, this can be 8. Length can be 1 and this length can be 8 with this 1. So 8 times 1 we can get 8. But is this the only option? There are other options also. Let's say if I have 2, if I have 4, this also can give me a rectangle. So I have to keep checking, because if I consider this as 1, this is the length and the same length is shared here. So if I consider this as 1, this can be 1. And if this is 1, this can be 16 to get the area. But if this is 16, can the length of this 10 be 16? Of course not. So if I keep checking one by one, finding out the values of one on one will take us a lot of time for each of the following rectangles. We don't have time for this. It's a so long method finding out one on one. And also you can switch the values. Length can be 4, width can be 2. This can also be interchanged. So can be a long journey to find out the length and width. So let's just see. Is there any method in which we can find out the areas of the shape without even finding the length and width? Let's just see. Let's take an example here. Let's just see. So let's say there is a big rectangle, and the big rectangle has 4 of the other rectangles similar to the shapes that we have. You can see all the rectangles that are present here. You can observe here. Let's observe the characteristic. The characteristic, as I just said, the length has the same sharing. It shares the same thing. For example, if you have a look at this length, the same length is also here, is also here. Here, the same part, that is this one. It's the same here, and same here. So it shares the common length and the widths that are present. And all the rectangles, see 1, 2, 3, 4, 5, 6, 7 and 8. All the 8 figures are inside one closed big rectangle. So this is the characteristic that we can observe. So many of the rectangles inside a big rectangle. So let's just see. Let's just start simple. Let's say 4 rectangles inside a big rectangle. Let's see what happens. The areas of these 4 rectangles, let's say it's A, B, C and D. Okay. And now the lengths that are present in here is nothing but, let's say for A, the length is 5. And for C, the width is 2. For A, the width is 3. And for B, it's 7. Now let me ask everyone you a question. We just know what is the area, right? What is the formula for area of A? If I want to calculate area of this A, how I can get it? Oh, it's just 5 multiplied with 3. So A is nothing but 5 times 3. What about B? How I can find out area of this B? Oh, to find out, here I have the length, that is 7. What about the width? What about this part? Oh, it shares the same. The length that is shared here is the same. So what we can do here is, oh, what happened? What we can do is, this is also 5. So here it's 5 times 7. Now let's say for C. For C, this is 2. And this part that we can observe here is the length. So length is nothing but just 3. It's opposite. So can term it as 3. Now, lastly, after C comes D. D is nothing but how much? Oh, technically, if you see, you cannot see any of the values. But let's just see. Here, this part is how much? Oh, this is 2. What about the length of this part? Oh, this is 7. So opposite is 7. So for D, how we can calculate area here, class? How we can? Oh, it's nothing but 2 times 7. So what we can observe here is, we can calculate the length and the width of the shape to 7. Now, Now, the problem is we got all the values, but let's just see if there is something that we can observe. For all the rectangles that are present here, there are sides that share the same length. That is, see, 5 has been shared, 3 has been shared, 7 has been shared, and 2 has been shared. So if you have a look at this part, you can see in A and B, you can see it's 5 and 5, which is the same. In C and D, 2 and 2 is the same. So, regarding the same sides, you can see there is one of the following part that is shared, that is same. But let's just compare the ones that are opposite. Let's say A and D. Is there any number that is common? Any? See, it's 5, 3, 2, and 7. None of the numbers are common. So let's say if I just multiply A and D. A and D is nothing but 5 multiplied by 3 multiplied by 2 multiplied by 7. What about C and B? Is there any number that is common? Ah, we can observe 2, 3, 5, and 7. There's no number that is common. And what if I multiply B and C? Let's just see. Let's just have a try. So if we multiply A and D, we can get 5 times 3, which is A, and 2 times 7, which is D. And B times C. B is how much? B is 5 times 7, and C is 2 times 3. I want you to observe. See, 5, 3, 2, 7. 5, 7, 2, 3. There are numbers on left side, on right side. If I multiply them, if I find out the value, which part will remain the same? All the numbers are the same. So the answer will be same. So I can say they are equal in nature. Wow, these are equal. So if this is equal, I can also say A times D and B times C is also equal. So what we can understand from this part, see, the part that we can understand here is, if there are rectangles inside any closed rectangles, see, there are 4 of the following rectangles, A, B, C and D. So what we can say is, when area of A and area of D is multiplied, see, area of A when multiplied with D, that is this cross, and when B is multiplied with C, with this cross, see this cross, when we multiply the rectangles which are opposite in nature, the area remains the same. And if you have a look at the figure, it looks something like this. See, it looks something like this. There is a word in Chinese. There is a word, there is a character in Chinese which is called like this. Can anyone tell me? Oh, this is called as the Thien model. So it looks something like Thien. That is the reason why we call it as Thien model. And for Thien model, we can observe in a figure which is made up of 4 or more rectangles which share common sides. We can say the product of areas of 2 opposite rectangles are equal. And this is what Thien model says. So in Thien model, what we can say, if there are rectangles that shares common side, it looks something like a window, you can see. Window. It looks like this is line and looks like a window. And in this window, if you want to find out areas of this rectangles, it's just cross multiply them. So let's just have a practice. Let's say here. Let's just see. So here I have 4 of the rectangles. I have to find out what is the area of this rectangle. So let's say if I call this as, this is 2, this is 4, this is 8, and this is question mark. As we just said, here in Thien model, when we multiply the opposite, the area remains the same. So when 2 is multiplied with question mark, the area of 8 times 4 should be the same. That is this one. Should be the same. So how to find out this part is the question. How to find out question mark? First of all, 8 times 4 is how much? It's 32. Now 2 multiplied with which number gives us 32? What we can do is we can just put 2 multiplied with which number is 32? 2 multiplied by 16 is 32. And to get it, it's 32 divided by 2, which is 16. So what we can understand from this part is, here, if we have in a closed rectangle 3 values, we can easily find out the value of the fourth rectangle, that is area, directly without finding out the side relation. So if this is the case, let's just see this question. Now in the question, I have A, I have B. Let me see. Let me mark. This is A. Let me use blue. Okay, this is A, this is B, and this is C. The question is, there has to be 4 rectangles inside a closed rectangle. So, can we find out what is the value of A here? Can we see? For A, there is this closed rectangle. And in this closed rectangle, we know value of the 3. Can we find out value of A? Can we? Of course. Here, we just have to multiply it in a cross. So 8 times 10 will be how much? 8 times 10 is nothing but 80. And which if I divide by 16, now the question arises here. 8 times 10 we can get, that is 80. But the thing is, how to find out A? Then we have to divide by 16. So the part that we have to pay attention on is the calculation. First, 8 times 10 you can multiply, that gives us 80. That is divided by 16 to give you just 5. So here we can get the value of A, that is 5. Then the next thing what you can do is just label that is 5. So we have got the value of A. Now let's just see how we can find out value of B here. Let's just see. Now for B, which are the 3 rectangles that we can observe? Oh, the closed rectangle. Remember, the side has to be sharing the same. So here, this is the rectangle that we are looking for. Now, here, the part that we have to pay attention on is 4 rectangles. Just multiply it in a cross. Let's just see this. Multiply by this. So 16 and 10. 16 times 10. To find out B, what we can do? 16 times 10. That is in a cross. And then this 8 can be divided. So my question is, 16 times 10 multiply by 8. 16 times 10 is 160. When 160 is divided by 8, what is the answer? You can directly divide 16 by 8 first. 16 divided by 8 is 2, and 2 times 10 is nothing but 20. So the area of P is nothing but 20, and you can mark it as soon as you get the answer. So here, in order to find out the value of B here, B is nothing but 20. Now comes the last part, that is, the problem is, the most challenging part is C. The question is how to find out value of C, but because C is not in a closed loop. See, if I consider this to be a closed loop, can I consider this? Do we know what is the value here? Of course not. The problem is we don't know what is the value of this part, so I cannot consider it to be closed loop. But we know the total part, that is 54. But in order to consider it to be a total part, this has to be considered, and in total this is the closed loop that we are looking for, where I have this line and this line. Now can we find out C? See, if you want to find out value of C, it looks something like this, where it is a closed loop where I have 4 of the rectangle, where this is 10. The triangle, the C, is present here, and this is 54. The question is how to find out this part. Oh, this is a sum. This is a sum of these 2 areas. So I can find out the sum of B, which is nothing but 16 plus 20, which is 36. So this area is nothing but 36. Now how to find out value of C is the question. So in order to find out the value of C, cross. Remember, cross. So the values that we know now is how much? What is the value? Oh, the only 2 values we know is 10 and 54. So it's 10 times 54, which we know, and which can be divided by which number? Oh, it's nothing but 36. Now my question is, 54 and 36. Is there any relation that is present? There is a relation of multiple that is present in both of them. You can divide it by 9. So here, if I divide by 36, the answer that we get, quite complex calculation, but I know you can do it. It's 15. So for C, the answer, the value that we are looking for is nothing but 15. Let me mark it on this paper. That is 15. So now class, we know A, we know B, we know C. How to find out the total area? The total is nothing but A plus B plus C. A is nothing but how much? Oh, fine. B is nothing but how much? Oh, 20. And C is nothing but how much? Oh, 15. So here, if we multiply, the answer here is 35. Oh, not 35. Oh no, who said it's 35? It's not. So here, what we can observe here is, it's 20, 15, 15, 20, 15. Oh, perfect. 15 plus 5, 20 plus 20, 40. So the most important part to understand from this question is nothing but about area. And if you have rectangles which is closed inside a big rectangle, which model we can use? It's called as, looks like Thien. So we call it as Thien model. And in Thien model, here, if there is a rectangle that shares common side, then we can say, we can find out the relation of the rectangles directly. So here the quick summary is about, if there are 4 of the rectangles present like A, B, C and D. So what we can do is, here just cross multiply and the area is same. A times D is nothing but B and C are in cross, so B times C. So in a figure made up of 4 or more rectangles which share side, the product of the areas of 2 opposite rectangles are equal. And this is what we can understand. So class, okay, first of all, I would like to apologize to everyone. I don't know what technical issue happened when I started off with the class. The stream suddenly stopped, and then I tried to make it more better. I just did impromptu. I closed everything. I just started off with the new link. I know because of which most of the parents have to switch back. Some of the parents have also messaged me that it was quite challenging for them to hear my voice. Uh, the voice issue, yeah, the things that have been catered. But the thing is, I wanted to apologize. Suddenly, as soon as I started, it happened. First of all, no worries. I'll take care of it. Any of the part after the class, if there's any problem, you can message me directly. I will teach you one on one. No need to worry about this. I'll make sure that part that we have covered today is understood by all the students. So, for the class for today, here the part that I wanted to explain to everyone, because of which we are conducting the open class, is the summary. First of all, about the perimeter. We know perimeter is nothing but calculating all outer boundaries. Then we saw area. Now, wrapper, remember the example wrapper and small pieces. Area is nothing but calculating what? The number of pieces. So here, calculating the number of 1 times 1 is called as area. And for a rectangle, the formula is length times breadth, out of which 3 values. If you know 2, you can get. Then comes square. For square, also side times side. If you know any one value, you can find out the other. Then comes the next part, that is the irregular shape. If you have a shape like staircase, you can use the push out method. And if you use the push out method, if you have vertical lines, you can move it to left and right. If you have horizontal lines, you can move it to top and bottom. And lastly, there is an interesting model we saw. Which one was it? Oh, model. So class, as I just said, if there's any of the trouble that has been caused from the today's class, I'm extremely sorry for all the inconveniences. but I'll make up for it after the class. I'll make sure I'll send the homework to everyone. Just try to attempt it. Also, if you have any of the doubts after the class, you can contact me on this number. This is my WhatsApp number. You can scan the QR code. You can contact me anytime. I'll make sure you run through this part really well. I want to make sure this. So the part is, if you like the video, you can share, send the like, or you can subscribe to our channel for this. The technically, I already knew that the open class will be longer than 1 hour because the content that I've designed was previously just 3 questions. But I thought it won't be more valuable. So to make it more valuable, I just added one more last question, that is the Thien model. But the main task is, if you understand all the parts really well, then it's worth a while. So if you have any of the doubts in any of the questions, you can get back to me. So for now, it's Teacher Smith signing off right now. I'll see you in the next open class and make sure that will be better than this one. Okay. So I'm signing off. I'll see everyone's message in the group chat. You can send a bye. Bye everyone. I'll see you soon. I'll message everyone. You can reply me over there. Thank you so much, everyone, for joining. Thank you so much for joining the session, everyone. To all my students, thank you so much for the patience, because know what it takes from switching back here and there just before the class, feeling that you might miss something or not. No worries, I'll take care of it. It's just, yeah, that's a bye. Okay. See you soon. You can send a bye message in our WhatsApp group, everyone. Okay, everyone. See you again. Bye bye. Thank you so much. Oh, oh. Thank you so much. Thank you so much for joining. Thank you so much. Thank you so much, everyone. Thank you. Bye, everyone. I'll see you on WhatsApp group chat. I'll reply you there. Bye.